The freedom of flight is only possible with careful attention to your aircraft. No matter where you're headed, get there safely with proper maintenance and regular inspections. Safety is paramount at Hartzell Aviation, where we build reliable products and power general aviation into the future. And we're growing, so let us introduce you to our family of companies. Hartzell Aviation's flagship is Hartzell Propeller, headquartered in Piqua, Ohio. Hartzell Propeller is the global leader in advanced aircraft propeller design and manufacturing technology for general aviation. Hartzell Service Center is where we provide aircraft propeller overhaul and repair. Hartzell Engine Tech is our leading OEM supplier and aerospace technology company. At Hartzell Aerospace Welding, you'll find an FAA Part 145 repair station and PMA holder for exhaust systems and engine mounts. Quality Aircraft Accessories, or QAA, is Hartzell's Part 145 Class 1 and Class 2 repair station with the in-house ability to overhaul most engine and airframe accessories. Today, we'll tap into expertise found across each of the Hartzell Aviation companies. Led by Hartzell Engine Tech's Director of Product and Technical Support, Alan Buffkin, we'll get maintenance and inspection guidance straight from the manufacturer.
I'm here in front of our Piper PA-44 Seminole. In this video, we'll be concentrating on two Hartzell Aviation products, our two-blade compact aluminum propeller and our Janitrol aircraft heating system. And to give us a deeper dive into the technical aspects of our propeller model, please welcome our Hartzell Propeller subject matter expert, Jareth Woody. Good to see you, buddy.
Absolutely, Alan. Great to be here.
Tell us more about yourself.
So I have approximately 12 years of aviation experience, encompassing various roles in military, GA, and commercial. I am currently a holder of a certified AMP and a licensed private pilot.
Well, behind us on your propeller, can you tell us more about what we would be looking for the daily pre-flight on this particular model?
So the pre-flight on this model, as you can see, is just the propeller up front. It's kind of hard to see everything, but we can get kind of a gist of everything that's on this propeller. Obviously, as this will be spinning, we want to be cautious of the flight arc or the prop arc. And as we're doing our inspection, we want to make sure those magnetos are turned off. We're going to look specifically at the blades, as corrosion, nicks, and gouges could give you stress risers along anywhere from the lead edge, trail edge, in the camber, and in the face. So we want to make sure that corrosion is not present, and if there is a nick that's anywhere between 31 thousandths of an inch deep, we want to address that and make it airworthy prior to flight. Additionally, we have a spinner assembly. This is a metal spinner assembly. And on here, we can tell a couple things as well in our pre-flight inspection. So we're looking for cracks on our spinner assembly. We can have a crack in up to 2 places on this metal spinner assembly, as long as it's touching a free edge. Out in space, it's usually a no-go. It's not permitted. But using your applicable field maintenance data, you can tell and further evaluate what that damage will look like and if it's acceptable for flight. Additionally, you'll note on here, we want to make sure that the propeller has adequate space between the blades and the spinner dome assembly. Sticking a light inside this gap, we can tell if there's either grease or oil leaking from the propeller blade, or if it goes further into the actual propeller assembly. One last thing on the pre-flight inspection that we could look for is actually the hardware that's installing this propeller to the engine flange. We can check for security and safety wire if it's applicable, and we just want to verify that it does exist, as this thing is rotating at very high speeds.
Would you stay with me so we could take a deeper dive, maybe into the 100-hour inspection?
It's a great idea, and we can definitely get a lot more information by taking this dome spinner off. Now that we've got this uncovered, we can definitely see a little bit more of the propeller. There's a really unique feature on this Dash 2 compact propeller, as you can see up front. It's the cylinder. So this cylinder has a preload, or a charge, inside there with either air or nitrogen. And at 100-hour inspections, it's actually required to check the pressure on this valve stem. It's also something that's a good practice during any type of scheduled maintenance. If the valve stem is leaking, it does need repair, as the control of this propeller is actually done through springs that are inside here and the air pressure itself to overcome the forces of the propeller blade and counterweights. We could look at the counterweights as well. So checking for any security, see that they're staked with pins and that they have corrosion prevention on them. We want to look for cracks on the actual counterweights themselves, as they could separate in flight, potentially, if a crack were left unresolved, and the actual hardware on the propeller itself. Additionally, while we're here, we can actually look at our lubrication fittings. If any of the lubrication fittings or the hub half is leaking oil or grease, we could resolve the issue now or get a certified repair station to do it as well. Looking back at the blade, again, we're looking for those arcing damage, potentially arcing damage through a lightning strike, which would come with brown residue or a black soot. We have to be a little more cognizant with the lightning strike, as this could fatigue the metal. And obviously, we don't want any part of this blade separating in flight. So if you have a look at the blade in a closer angle, some of the things that we'll find along the lead edge are chips, nicks, scratches, and dings. Some of them are airworthy, and others are past the applicable owner's manual or field maintenance manuals will require repair prior to flight. Additionally, we want to make sure that no corrosion on the blade is present, or we repair the corrosion and cover it with the appropriate corrosion prevention such as paint and allodyne prior to flight. Here we have a bulkhead installed on our propeller assembly, and we can actually look closer at the rivets. And from the rear side, with the cowlings removed, we can actually look at our doubler for any potential cracks or damage that may be propagating.
I know we look for different types of radial play in composite. Is it the same type of inspection for an aluminum blade? And also, because of the hub, is there any grease or anything, or is this different from a composite blade that I need to be paying attention to?
It's very similar to two types of propellers. With the composite blade or the aluminum blade, we still want to check for our radial play. And in this configuration, we want to make sure that the blades are what's called preloaded. This happens during shutdown and startup of the propeller blade. We want to make sure that the propeller blade is seated within the hub socket and there's tension on the blade. Additionally, we want to make sure that there's no oil or grease coming from the O-ring seals or the blade seals of the propeller assembly. We can use a UV light, which can detect the difference between grease and oil through the photoluminescent properties of the additive of the engine oil. The lubrication of the propeller assembly is also very important. So the cylinder should be placarded with the appropriate lubrication. We don't want to mix the synthetic GN 3058 grease, the NICO, with any aeroshell product, as the two mixing together could degrade the grease properties. When you're in doubt and you do your visual inspection and you want to go further with the evaluation portion, you can actually consult any of your applicable owner's manuals or field maintenance manuals, or even get the help of a trained A&P mechanic.
I appreciate you coming out today and sharing your knowledge with us. I hope to see you again soon.
Absolutely. Been a pleasure.
Now let's move forward and focus our attention to the Janitrol cabin heater. So here we are on this PA44. This is a pretty standard Janitrol installation. There are three types of heaters primarily you'll find on various aircraft. In the applications, you'll find a south wind heater, you will find a Janitrol, you'll also find C&D. All of those heaters are primarily conceptually the same, but they do have varied differences across the brands. All of them pretty much function the same, but might have different apparatuses. Today, we're going to specifically focus on this particular Janitrol heater in this Piper PA44. Now, across different airframes as well, there can be different setups. This particular system, we're going to start with the fuel system and work our way back. In this aircraft, of course, we have a mechanical fuel pump to a fuel pressure regulator, to the heater itself, to the solenoid. Some aircraft might actually be fueled from the engine-driven fuel pumps through a pressure regulator to the heater directly. Some, in the case of a south wind, could be a rotary-driven pump from the combustion air that's supplying the fuel to the heater. So there are variances, but in this particular case for our heater here, this is a mechanical fuel pump fed heater. Main components of the heater, I'll name them off. We have our combustion air assembly, which is of course the fan assembly and the motor. This is to supply combustion air to the combustion chamber. You have a combustion air pressure switch. This pressure switch senses whether or not there is combustion air present. It is a diaphragm differential pressure actuated switch, so the air actually moves the switch on or off. It is also a fail-safe in the system for if combustion air wasn't present, it won't let the heater light. In combination with the combustion air pressure switch, we have our over-temp switch. Our over-temp switch in itself too, if the temperature was to exceed, will pop, it opens the circuit, won't allow power to flow or the heater to operate. Below it, we have the heater itself. Inside the heater in this section is our vent air fan. Of course, we'll have scarfed air coming from outside into the heater. Mostly in flight, it's augmented. This is pressurized air from the forward speed of flight coming in. But on the ground, you do have a vent air fan motor, which will move that air over the combustion chamber to extract that heat from the combustion chamber to bring in and heat the cabin. There you have the combustion chamber itself. The combustion chamber consists of it in itself, the spark plug, our igniter assembly, as well as our fuel nozzle and fuel solenoid. That in itself is our ignition system and our fuel source. In this particular aircraft, our fuel source runs back, of course, to our fuel shutoff, to our mechanical fuel pump. The heater itself for the backside, of course, you have your terminal strip, which is where everything connects. This works off a successional terminal strip, so as things on this heater from switching to the various components all run down a switch series system in line as part of the safety feature too of the combustion air or the overheat switch to let the heater not operate should one of these systems incur a problem. There are other outside things that are attached to the heater as well. These are from inside the cabin, of course, to control our vent outside air fan. We also have a cycling switch, which is located on the heater. Some aircraft in application too will have a duct air switch, which will work in conjunction with the cycling switch. It's usually a little further down the cabin, and that's tied into our cabin heater, either rotary rheostat or linear push-pull type of rheostat, which controls our on, off, fan, high, low, or medium temperature settings for the heater. Now, focusing strictly on our installation we have here, a good overview of this heater, if I was to come here, open up and just want to take a quick look for security of the heater itself, the first thing I'm going to start with as I'm in here is my fuel lines. I'm going to work my way down my fuel lines, my fuel pump all the way down. I'm looking for any stained blue dye, any dripping fuel, anything that looks like a chafed wire, anything out of the ordinary that doesn't look proper. Looking at wiring and grounding as well, all the way up to the fuel solenoid of the heater. Now in this particular instance, I have removed the heater fuel solenoid cover prior to filming this video to show that. But also inside of the fuel solenoid chamber, we want to make sure that rubber grommets are in line with our cover when we put the cover on. We want to make sure that we have no fuel dripping, no blue dye showing. The solenoid wiring is in good shape. We want to check our fittings as it goes to the fuel nozzle itself to make sure that everything looks good, no fuel is present. We also want to work our wiring back from the fuel solenoid, making sure that nothing is chafed as well. As we come up to the heater as a whole, after looking at the fuel system, I'm going to start checking. What I always like to start checking with first is the actual terminal strip. Heaters in aircraft, depending on the aircraft they can experience pretty high vibration. Most of them are band clamped into the nose. You have combustion air, which might be on a stringer girder across. In the case of some Cessnas, depending where it might be mounted to the airframe. Could be mounted on the heater, as of this case, but they do incur a lot of vibration. You have your combustion air motor, as well as your vent air fan motor, plus the vibration of the aircraft. I always like to look at the terminal strip first, make sure all of my terminal ends and screws are good and secure, nothing has come loose, all of it looks completely normal, no chafing, and that none of the wires have been pulled from the terminal leads. Good security there means we got good connection, everything will work properly. I like to take my terminal strip and I'll divide it in systems. I'll run my terminal strip over to my overheat switch, make sure my wiring is in good condition, the switch in itself is in good condition, no corrosion. I also will work my way back from that to the ignition. I'll check all my ignition leads, my power lead to the terminal strip, make sure there's no chafing. I'll check for general security to make sure that the wire bundles are still together. I'll also work my way up from that strip to the actual vent air fan assembly, make sure all my wiring's secure and is intact. I'll make my way back past the fuel solenoid, checking it again for its security, all the way to the rubber grommet, which leads to the vent fan. Everything there looks good and secure. This blue and black wire is leading off from that as well, which is our combustion air wire. I'll check it for security. Here we have tape for vibration to make sure that nothing chafes. And that's generally what we're looking for, is the shape of the wiring. The ignition assembly too, I'll check that the vibrator assembly pack, the igniter pack, and the assembly as a whole is secure. Nothing seems loose or out of the ordinary. I'm also going to check my ignition lead to the spark plug in itself. I'll check my rubber grommet around my spark plug, which is basically there as an anti-chafe as well as to capture heat going through. It's sort of to keep you from losing heated air coming across, but it's part of our security check that we want to make. We're going to check that for security, make sure everything's tight there. Nothing looks out of the ordinary, nothing looks loose. The combustion air in itself, I usually like to check it for general security, make sure it's tight. Here we have some aluminum scat hose, which is solid all the way up, with a little bit of rubber hose over the end to make a seal. But this particular hose being solid in nature, you want to make sure it's secured at the rear and the front, and that it's not going to move or come off so you don't lose combustion air. Here, coming through that combustion air for the combustion air into the chamber, we have a little bit of heat tape. These are secured with screws, which attach to this elbow assembly, so they are secured, but a little bit of tape on here in this case is just ensuring that we get 100% or as much as we can of that combustion air into the combustion chamber without overboarding or losing any. Our combustion air motor, it is a rubber mount because once again there is vibration. We want to check that clamp, make sure it's secure, and of course we've already checked our wiring. Now, one of the things about heaters, they usually sit up front. They sit in probably weren't really a very corrosive environment. They're taking things from the outside inside of the vent air fan. They do get hot and cold as they go through the cycles. You will build corrosion. It's unavoidable on a heater, but as you can see in this case, all our terminal ends, even our front terminal ends for some of our aircraft operated vent air fan inlet and outlet actuator is completely fine. A little bit of corrosion, but not bad. But the heater itself is in great shape. Lastly, one thing I like to do too is the heater as a whole. I like to take the heater, move the heater, make sure that the heater in its clamps, whichever fashion it might be in, is secure, and that the security of where it is attached to the inlet for the aircraft, the V-band clamp in this case, is secure, and that all wires, etc., that are attached to that for other operations that run by the heater are out of the way, secure, no chafing, no problems there. So as we've inspected this heater, we've gone over this, it pretty much also encompasses 100 hour. Depending on the heater, there could be some more, some less, depending upon checks that would be required for that time frame. One of the other additional things that you will want to look at as well, though, is to make sure your combustion air hoses, your overboard fuel drain lines, which are also located underneath the heater, as well as the heater's exhaust, is free and clear of any debris, clog, or could possibly be leaking if dry rotted, etc. rubber hoses for some of our fuel drains. All of the heater, depending on part number of the heater, you must reference the applicable maintenance manual, not only from the heater manufacturer, but for the model of heater of that manufacturer. Whether it be a Southwind, a Janitrol, or C&D, some have different ICA recommendations and time depending on the component that we have of the heater that we're either inspecting or looking at for that 100, 250, 500 hour inspection. As well, combustion air assemblies do have different model numbers, as well as fuel pumps and other fuel shutoff valves or fuel pressure regulators. Some of those have individual manuals for themselves depending on what brand it is. About every 30 to 90 days, you need to be operating the heater. Remember, you have fuel sitting in this system. You need to cycle the old fuel with new fuel through. Regardless of what model or brand heater you have, as long as it's properly maintained and kept up with the appropriate maintenance manual, a heater properly maintained is a safe heater. I hope you have enjoyed this video on our Piper PA44 Seminole. I'd also like to thank our subject matter expert for participating in this video. At Hartzell Aviation, we are dedicated to providing aviation products and services that deliver uncompromising quality, performance, and support. If you would like to contact us directly or learn more, please visit us at hartzellaviation.com.